Hi, my name is Lisa Richter. I'm Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help SIs build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. In fact, the BP committee has just soft launched a beta version of the latest manual, which is 6.0. CSIA also offers a certification program and other resources, including professional development, learning from your peers, and access to vetted professional services companies, including insurance, financial, and legal, who understand the SI's unique business needs. For partner members, CSIA offers an ecosystem to grow their SI programs, understand their customers' pain points, monitor industry trends, and share their thought leadership. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources, from accounting to sales to operations, 365 days per year. If you are currently a member, thank you. If you want to just get a flavor of CSI and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSI members talk all things industrial automation, and it's just a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. That just helps us stay organized. The session is being recorded, and you will get a link to the recording in the next day or so. At this time, I would like to turn it over to today's speakers. Take it away, guys.
All right, this will help if I come off of mute. Hey, thanks, Lisa. Great introduction. My name's Tim Ogden, and I'm the director of the SI programs here at GE Digital. And I'd like to thank everybody for taking the time to participate in today's CSIA Masterclass on leveraging industrial data for better decision making. Now, GE is a CSIA partner member, and we've been fairly proactive with CSIA as participating members of, the Digital Transformation Committee. And then we recently participated on a panel discussion on making money using digital tools and at the CSI executive event. And the whole goal here is really to find new revenue opportunities and help systems integrators that want to dive into new industries and markets to generate additional revenue. We want to be there to help you. We've been manufacturers are focused on manufacturing for over 30 years, and GE is a little bit unique in that we're 100% focused on developing software tools for industrial automation and manufacturing execution. So we're hardware agnostic. We've got over 500,000 software installations globally at more than 20,000 customers around the world. So we've got a lot of experience with software applications around the globe. So in today's session, we're going to discuss a real-world approach on how systems integrators can leverage analytics software tools to improve your customer's bottom line, and doing this all while generating some new revenue streams. So at GE, over 95% of all of our digital software installs are implemented by our SI community. So we really appreciate taking the time to join us and learn a little bit more. Today, our subject matter expert is Cobus Vanderheiden. He's a senior product manager for analytics and machine learning here at GE Digital. He's got 20 plus years of experience in developing and implementing industrial software. So he's got a ton of expertise, and he's seen a lot of different applications out there. He really specializes in helping customers apply the technology of advanced analytics and machine learning, and really to realize transformational productivity gains and really help take customers more from a reactive approach to a predictive and preventative type situation for manufacturing. So with that said, I'm going to turn it over to Cobus and let him go.
Thank you, Tim. Appreciate that. Hello to everyone. Let me share my screen. Just give me a moment here to share my screen. Tim, just give me some feedback. Can you see the screen?
Yep, we're all good. Go for it.
Wonderful. Thank you. So hello, everyone. What a wonderful privilege to spend this hour with you today. My name is Cobus van Heerden. I am a product manager at GE Digital, and like Tim said, it's a pleasure to be with you talking about how system integrators can help your customers essentially leverage their industrial data to get more value using analytics. And it's really a pleasure to share our experience and to explore how we as GE Digital can partner with you, with our system integrator communities, also to help you create new revenue streams and new value for your customers. So I think a few facts or the reality out there is that industrial manufacturing and industrial customers out there have no shortage of data. If you look right across the automation software stack from the control systems, PLCs, DCSs to the SCADAs, up through the MES, essentially the operational software are all creating a lot of data, and that data, operational data, is being stored in various systems, and so there is a lot of data across the value chain. Even if you think about how industrial manufacturers or industrial companies operate, maybe they're making some products and there's raw material data, there's sensor data of how the process runs, there is maybe production contextual data generated through management execution systems, there all the way to maybe quality data. So there's a lot of data. And, the question is, how can the system integrator community partner with your customers to start to help them to leverage the available data with the later available of analytics, machine learning, and those kinds of software tools to add new value, to unlock new value, to optimize their operations. And also in doing so, essentially build new competencies within your own system integrator businesses, but also create new revenue streams for yourselves. Well, the good news is that easy to use analytic software exists in the market, and now to the point where engineers, subject matter experts, engineers like control engineers or process engineers, the people who know the processes within your businesses, for example, or those of your customers, can unlock a lot of value using the software without having to be data scientists and having to have PhDs in mathematics or statistics, for example. And so really it is the subject matter experts, people like yourselves, people who are, let's say, used to providing services to integrate the operational software for your customers, but also partnering with the domain experts of your customers, process engineers, control engineers, to really add a lot of value using these new software tools to utilize the data from operational software to optimize the customer's productivity. And so essentially, how this generally plays out is, like I said, operational software generates a lot of data. And the fact is, industrial manufacturing plants aim to operate at maximum productivity. So maximum productivity may be, if you think in terms of OEE, overall equipment effectiveness, you're striving for 100%, right? Meaning you are, producing as much as possible, or exactly the planned amount at perfect quality, just good enough quality, with always up, 100% uptime at sort of maximum efficiency, maybe minimum cost per unit produced, or minimum energy and utility usage, etc., etc. Whatever performance means to our customers, the fact is that they're not always producing at optimal levels. There is always, let's say, 10 to 20% or more productivity left that can be essentially squeezed out of existing factories through just optimization technologies like analytics, machine learning, and optimization software. And how do you do that? It's really the truth is that one of the biggest enemies of 100% of optimal productivity is variation in performance. So performance variation comes from many places. They can come through variation in raw material quality from maybe your suppliers. The quality of the raw materials vary and you have limited control over that. Or, the ambient conditions within which you operate or produce varies. Or human behavior. Maybe your operators are making inconsistent choices, and in terms of taking inconsistent, suboptimal, maybe manual actions in areas which has not yet been automated, and so forth. There can be various reasons for variation in performance. And what analytics and analytics and optimization software really allows customers and system integrators like yourselves to do is to really understand that variation, to minimize the variation, and then to optimize, continuously improve and optimize the process. And that really results in improved throughput, yield, quality, efficiency, often 10% or more for customers, which can be significant. And so generally, the value of optimization, like I say, generally in industrial plants, there is, let's say, 10 to 20% in our experience, room for productivity improvement through optimization. And now just, if you pause for a moment and think about that, in a 10-plant enterprise, if you improve the productivity of each plant by 10%, you have essentially unlocked one whole new manufacturing plant that you do not have to build, that was just hidden capacity inside your existing plants. So that can possibly be the value of optimization. And that is unlocked really by utilizing available, easy to use analytics and optimization software on top of the data from operational software that's already present, like your SCADAs, your PLCs, DCSs, your MES systems, to really understand variation through analysis, and then to reduce variation in performance. And when I say performance, it can be variation in throughput, it can be variation in quality, it can be variation in energy efficiency, it can be variation in any performance metric that's important to your customers. But essentially then, reduce variation through deploying analytics to monitor the various layers of your operations, to early detect issues, and then, essentially becoming more predictive by deploying analytics that can predict performance more proactively, so you can essentially be more proactive instead of reactive. And then lastly, once you've reduced variation, you can really then optimize the way you run the plant, and specifically the settings that you use on the plant, to consistently run at optimal or maximum productivity. And so essentially understand variation, reduce variation, and then optimize the process. That is how value is delivered through analytics software for industrial manufacturing companies. And so to do that, generally, these software products that are available, essentially, and also when you as system integrator, control system integrator, companies look at the capabilities required to deliver this kind of value, you should generally look for or think about 5 capabilities, meaning, you should look for manufacturing software or analytic software that can analyze, monitor, predict, simulate, and optimize performance of industrial plants. Around analysis, it's really you require easy analysis tools, which goes beyond simple trending, of historical data, that leverage machine learning and analytics to really empower subject matter experts like control or process engineers to really answer all their why questions really quickly, meaning, hey, why has the throughput been down yesterday? Why are we making bad quality production? All those why questions, to sort of mine the answers, to mine the causes, the root causes, identify, and also to mine that rapidly from available historical data, to just gain insight on how can we improve the process. So analysis capabilities, advanced analysis capabilities, but sort of driven by the latest analytics in ML, empowering the subject matter expert, the engineer, that's really important. Secondly, and that will enable you to understand variation. Secondly, you want to really look for capabilities where you can configure monitoring on various layers. For example, you want to monitor things like the health of sensors, control loops, equipment, and process units in your customers' plants, or help them to do that through analytics for the purposes of really earlier detecting possible upsets or issues earlier than traditional alarm systems would do, that are just based on simple high-low thresholds. And that's really just so that you can, again, avoid variation, reduce variation, and just avoid some of these upsets by detecting them earlier. Then you want to look for prediction capabilities. So the ability to leverage the latest easy machine learning and sort of analytics to create data-driven models that can predict or forecast quality or throughput, or whether it's energy usage. In other words, performance, predict and forecast performance, again with the aim of reducing variation and acting more proactively, and possibly in real time controlling more proactively, in a more predictive sense, performance in your industrial plant. Lastly, you should look for the ability to model process units or assets, the behavior of these, through easily creating digital twin behavioral models that can describe the behavior or simulate or model the behavior of a process or an asset, really just for the purpose of maybe accelerating or supporting decision making offline, or whether it's online, maybe what if simulations, just more accurate and faster decision making at a lower cost, because sometimes to experiment on the live process can be expensive, can be really slow, and sometimes even dangerous, sometimes not even possible. And so through the ability to easily create digital twin models, whether they are first principles based or machine learning data driven based, if you don't really understand the first principles or the physics and you have a lot of data, it's really valuable to support your optimization efforts. And then lastly, you really want to look for real-time and optimization capabilities like advanced process control, real-time set point optimizers, the ability to, take what you have learned from analytics, to take these process digital twin models, to take the insights that you've gained, and really add optimizers to those that can continuously in real time, and possibly even closed loop, through closed loop control, really recommend or calculate the best set points, the best settings, the optimal way to run the plant continuously, so that you continuously and consistently operate at optimal performance, be that throughput, quality, etc. And typically in our experience, In that way, we are seeing customers increasing productivity often by 10% or more. And so on this slide is just a couple of, it's really just a summary to give you a sense of some case stories in our experience of how different manufacturing industrial plants and enterprises in different industries are applying these different capabilities to improve, to gain improvement. And what you're going to see here is again, just the overarching statement that often up to 10% or even more productivity or improvements are possible in things like throughput or quality or efficiency by leveraging analytics and optimization software on top of whatever mixture of OT software systems a customer may already have, by utilizing the data from those systems, from raw materials right through to end product quality, for example. So you will see, food companies, water companies, energy, paper, building materials, metals, mining, and really just across manufacturing industries, companies really analyzing, monitoring, predicting, simulating, optimizing their plants using industrial software. And if you want to, this one of these specific products that GE Digital offers that enable all of these capabilities are a product called Prophecy C-Sense. And if you see the link there on the screen, if you are interested to read detailed case stories similar to what you see on the screen here, feel free to go there on to see how customers are unlocking that value. And though that gives you a sense of the kind of value that you, control system integrators, who already have the relationship with those customers, because you probably implemented the SCADA system, or you may have implemented or configured the MES system. So you already have those, or maybe you have implemented the historian, the process historian. You already have those relationships. You have access to those data sources, and you can now go back to your same customer and also offer optimization services and solutions to them using some of these products, for example, Prophecy C-Sense. And so let's look at these real briefly. So essentially what we're seeing is, firstly, it's important that you look for easy analysis capabilities, using analytics, visual, easy, rapid analysis capabilities beyond just simple trending. And, what you're seeing here is essentially how Prophecy C-Sense and has easy analysis tools can enable engineers, your engineers as a solution provider to your customers, but also the customer's process and control engineers, to really easily use data from the various systems, whether it's raw materials, process historians, MES, final product quality, combine that data together and really answer questions like, hey, why is our production down? Hey, why is my quality varying? Hey, why are some of our batches different from other batches? And so I think I just want to highlight with a slide that, again, the first area of value where often rapid value comes, even within hours, is where you bring data together from raw materials, historian, maybe sensors from your MES, from raw material, from your final product quality, and you just correlate how your raw materials, your sensor, how you're controlling your sensors, to how it affects final product quality, how all these things affect one another. And often there are rapid insights that pop out that, gee whiz, if we just do this, if we just go and turn that knob, if we just switch that thing off or to a different set point, or maybe we just don't take raw materials from this supplier, rather that supplier, or if we do get raw materials from this supplier, rather control the process slightly differently, customers can unlock lots of value with simple insights in a matter of hours. Secondly, you want to really start to deploy monitoring on various layers. And one of the simple ways is one of the most basic layers is just the sensors. So, in manufacturing industrial plants, there are many, many sensors, and sensors produces the data, and often they may stop working. They may produce bad quality data, or they may be flatlining. And so just deploying very simple health monitoring on your sensors can already provide real quick value, in the sense that at any moment I can draw up a report that shows me for the last day which sensors have been most unhealthy, or have been unhealthy, or had issues. And it doesn't mean you have to deploy this kind of thing to all sensors, but you can focus on sensors which you deem to be critical. Or it also doesn't mean that this has to be super rocket science, but this can just be monitoring for basic things like, hey, this sensor is producing bad quality, it's flatlining, or hey, this sensor is out of normal or good limits. And in this case, analytics can, for example, learn what is normal limits. And they can learn unique normal limits from historical data available in the historian, based on, unique for every product or operating mode the plant is typically in. Or if you're operating a batch process, as you go through the batch, it can learn the specific normal profile within which certain sensors should be. And so just simple sensor health can sort of be some first layer of monitoring value. But then on top of that, PID control loops is the next really critical layer. I mean, I always say there is no point in trying to do fancy optimization in an industrial plant where the PID control loops are not properly maintained and tuned and working very, very well. And therefore, any comprehensive optimization solution should include integrated comprehensive PID performance monitoring, as well as tuning and modeling capabilities. And so that is exactly what you would find in Prophecy C-Sense, where out of the box you can configure very quickly all the PID control loops. Now, if you are in a continuous manufacturing plant, that may be hundreds to even possibly thousands. If you are in a batch type of plant, it may be hundreds. In a discrete processing plant, there may be few. But there are normally always quite a number of PID control loops, typically in PLCs or DCSs or in your SCADAs configured. And the idea here is that that you can use analytics to just monitor their performance, and at any time pull a report on what is the performance of all my loops, which are the worst performing loops, and that may need tuning. And if they may need tuning, then you have easy integrated tools to use the historical data to model their behavior, and then also to calculate the optimal PID tuning parameters, which you can then easily go and update in the PLC or DCS or SCADA system where they are executing. The next layer is really process or equipment health monitoring. And so, it can be very valuable, not a big bang approach, but selectively pick critical assets to say, hey, I want to monitor the health of this pump or that part of the process to detect any anomalies as early as possible, possibly earlier than simple like high-low threshold alarms in the SCADA or DCS would do, by using machine learning or analytic, more multivariate approaches. And so, in this example, for example, a pump may be one such example, where you can just do simple things like just calculate pump efficiency in real time through a simple analytic, and then make that available and put alerts on pump efficiency. So for all pumps what their real-time efficiency is, and you can actually detect when any pump is operating at less than optimal efficiency. Or you can make like a multivariate fingerprint model of normal behavior of all the sensors around a piece of equipment or a process region like a pump. And in a case like this, this example, detect that something is the behavior of the pump is becoming abnormal, let's say about 16 days before otherwise a shutdown or failure event would have occurred. And that just adds early warning and early detection. Now, if we move on to prediction, one of the prediction is really that a comprehensive optimization and analytic solution should enable easy machine learning where you do not necessarily require super duper data scientists, but you can utilize the data scientists you do have, and you can collaborate with the data scientists that are available. So environment which allows data scientists to collaborate with subject matter experts like control and or process engineers or even maintenance engineers, to easily create machine learning models to predict performance in real time. So you can use it for real-time control and for real-time actions or alerts. And one very common use case is essentially that in manufacturing plants, often quality is managed through laboratory samples, which means you don't have a real-time measurement of quality. Now, I know sensor technologies are progressing, and more through vision systems and this and that, you can have more real-time quality let's say, sensing. But still, we often measure through lab quality samples, which are infrequent and after the effect becomes available. So, that's just one example where you can create possibly a machine learning model to predict or estimate quality in real time. So you train it based on the historical data from the lab and other associated process data. And that means that the system can now use only the other associated process data to in real time estimate or predict what the quality would be at every moment in time, which you can use for real-time control, real-time quality control. And you can possibly choose that only when the model predicts that the quality will be bad, then you do a lab test. And so forth, you can possibly run at real-time quality control with maintaining the same sort of quality levels, possibly even reducing laboratory testing and maintaining the same sort of statistical quality levels. So, quality prediction is often a use case for productivity. But the point here is that machine learning, easy machine learning, so like one-click machine learning models for engineers, which does not require data scientists, or in this environment, you have full Python capabilities. Also, if you do have data scientists that want to do fancy other custom algorithm-based machine learning models. And then lastly, I'll just close. So let's talk about optimization. So the optimization capabilities. I think it's, analytics is great if it can bring you new insights or if you can monitor and raise an alert. But the point is a human still need to take action based on an alert. Or if you can predict something is going to happen, but it really becomes most valuable if you can take the action automatically. Obviously, where it is possible and safe. That's really important. And so I think closing the loop on analytics is where the real value lies. Closing the loop on optimization, on optimizers, is where the real value lies. And one example of that is that you need to make sure that the optimization software you use can have all these capabilities from analysis to closed loop optimization and control. And so in this example, Prophecy CSense enables full advanced control, model predictive control, and also real-time optimization capabilities. In this picture, you see here a multivariate model predictive controller. That's typically a more advanced approach than PID loop. So often, your base layer control, your safety systems will always be in the PLC on the DCS to keep the plant running safely. But then on top of that, you may want to optimize the set points through real-time set point optimization, fine-tune really to get the maximum out of the plant, while you ensure you've tuned those base layer controls to be really optimal and stable. And sometimes PID loops are not sufficient, and then you need more advanced techniques. And so all of that, make sure that whatever optimization software you choose that sits on top of these OT systems and control systems have full advanced control and real-time optimization capabilities. And so I'm just showing a typical sort of high-level architecture, really just information flow diagram here using Prophecy CSense as an example. But such optimization software then typically interacts with your real-time control systems, with whether it's the PLC or the DCS or the SCADA via real-time interface standards like OPC. And with your process historians for sensor data, either read from or write to. For example, if you want to train a machine learning model on historical data, you want to get the historical sensor data from the historian. Also, it would interface with your other transactional data systems, like your MES or maybe your raw materials or your lab quality systems. They are often sort of relational database based, for example, SQL based. And so the optimization or analytics solution typically grab data from these various systems. It would be from your control systems in real time, maybe historical data as necessary from the sensor data from the historian, or production context, raw materials or quality data from database systems like SQL or your various MES raw materials or quality databases. To then essentially analyze, model, predict, simulate, and optimize process performance, and then producing things like alerts or predictions or optimal set points, which are again written back to your control systems, maybe to control the plant, but also historized maybe back into your historian. And then with your typical visualization and reporting tools sitting on top of those typical systems that can really visualize the results that are being produced by these analytics solutions. What's also really important is that you look at how, where this analytics can run, and that you pick a product or you pick a solution which not only cover all these capabilities, but it's as flexible deployment options. So, you really want to be able, when you do closed loop control, you really want to be on premise close to the control systems for real-time control actions that are reliable and safe. But sometimes you also want to, run some analytics that can analyze data maybe from across multiple sites. So you may want also, in addition to, so typically you would put a, one sort of analytics runtime instance on every plant close to the control systems for real-time critical closed loop control. But you may also want, analytics runtime instance more on an enterprise level, on a, centralized level, maybe close to an enterprise historian, where it can act on data across different plants, and maybe even in the cloud. So maybe in your virtual private cloud, if the customer has AWS or Azure or virtual private cloud environments, you can, and you are centralizing some of the data there that looks across the plants, you can put some instances of the analytics runtimes there that can do the less critical, maybe more the monitoring or the analysis across data from multiple plants. Because sometimes maybe some of your subject matter expertise are local at the plant, looking at a specific plant production, but you may also have centralized teams, centers of excellence that are maybe remotely optimizing or analyzing or multiple plants, and they may want to, deploy analytics or work with analytics in a more centralized fashion. So it's important that analytics can run wherever the use case demand, meaning closed loop control typically on site near the control system, more monitoring, less time sensitive, or analysis maybe more centralized if necessary. Okay, so now I'm just going to go through a few, I'm going to, give you a few concepts around, what to look for when you pick a solution that can support optimization or enable you to build a practice to support optimization to your customers. And the first important thing here is simply to look for a comprehensive solution. The analytics industry is quite fragmented. A lot of the capabilities I've just mentioned are typically offered by different products through different vendors. Some are small, some are startups. So look for a comprehensive solution that really covers all the way through, help you understand, minimize and optimize variation, that all the way from analysis through to closed loop control and optimization. So it's sort of simplify your world and enable you to take a customer on a journey, because sometimes they want to start just with some simple pump efficiency calculations, right? And then they want to progress to prediction and maybe later on to closed loop control. And you don't want to have to apply 10 different products for each different use case. And so firstly, I think also really important to really build your practices and enable your customers with trusted, proven solutions. Like I say, the analytics industry, the AI, ML industry, that is really one of the very fast moving industries. It's quite fragmented at the moment. And so really, it's really important to partner with a globally trusted vendor that can, support you and your your customers with proven software, and that will not go away tomorrow. Secondly, we've looked at the various capabilities: analyze, monitor, predict, simulate, optimized. If we just pause at analyze for a moment, I think it's really important to look for software that enables easy analysis beyond simple trending. I think in the analysis, simple analysis, intuitive, visual, explorative analysis guided by machine learning techniques, but in the background, enabling an engineer just to get their questions answered. In fact, enabling you as a system integrator to possibly provide consulting services to customers around using some of these tools to analyze some of their data maybe for them. But because I find often that customers they have the subject matter experts, but they are busy. They're busy running their operations, and so look for powerful analysis tools with which either you or the customer within a matter of hours can unlock new insights that can possibly drive transformational gains, really just out of the gates in a matter of hours. Also, I think look for a solution that enables rapid solution development, in an iterative, visual, drag and drop kind of analytics building environment, that enables really, again, a collaboration between subject matter experts and the different personas, maybe data scientists, and you and your customers to build reusable libraries of analytic components. And that's also where you can possibly add lots of value. Maybe you have deep domain expertise around a certain area of the process, and you can build analytic templates, right, for that area, for the customer, that you can essentially make available to the customer, maybe to your customers, as functional libraries. So I think rapid prototyping, rapid development and testing environments, visual drag and drop is really important to look for. Also, the ability, like I said on the previous slide, to really create templates and to utilize templates, to modular development, the ability to create reusable content that can be made available to your customers, even as templates around specific assets or types of processes. Also, again, it's really important that a lot of analytics techniques are really aimed at data scientists. So it requires programming skills, it requires deep understanding of machine learning algorithms and statistics and mathematics. So, but the good news is that products exist now, like Prophecy C-Sense, which really built with engineers in mind. So in other words, the process engineers, the control engineers, the people who know the process and the assets, they can leverage it. And so I think that's a really key thing, to pick a solution, to build a practice, which does not necessarily make you totally dependent on data scientists and programmers to deliver value for your customers. Then I think you need to think about scaling. So, make sure this is a proven capability that can really, sort of be industrial grade, so to speak. It's not experimental, and with which you can rapidly do rapid small POCs. But if those POCs, proof of concepts, proof of values, if they are successful, then you can essentially replicate that and deploy that maybe throughout a plant on similar assets, or maybe through a center of excellence, if you are serving an enterprise with multiple plants, can deploy that same solution template, let's say, to other plants quite quickly, And so you can really scale up the value, because essentially what you want is to enable collaboration and scale between plants and centers of excellence that are centralized, that can remotely serve and help to optimize, provide service optimization services, maybe monitoring services, maybe consulting services to customers, and easily scale that, whether it's across plants or in a specific plant. And then maybe some closing thoughts for me here is that there are real benefits. I would, in my experience, say up to 10% of more productivity improvement. And if you think about that across 10 plants, that means one fully hidden, new, additional manufacturing plant that your customer do not have to build, that can be unlocked just through optimization analytics, using the availability data from diverse operational software systems that you probably have installed or configured for your customer, or is maintaining for your customer. And the reason why that's there is because often these OT data are siloed. It is just too much for humans to analyze. But the analytics software that exists today makes it easy to combine that data and really from that unlock optimization opportunities and really just improve performance of the plant, whether that is quality improvement, throughput improvement, improved efficiency, yield, reducing downtime, like I said, by up to 10% often or more. And so before we go to Q&A and give you guys and ladies a chance to ask questions, just a few more resources I want to make you aware of. So the solution I've been referencing is Prophecy CSense. The latest version is version 2023 that we released this year. It's really provides industrial analytics capability for our Prophecy software suite, the GE Digital Prophecy software suite. And it's really designed for engineers in mind. It provides 5-in-1 comprehensive capabilities, from analysis through to monitoring, prediction, simulation, to closed loop optimization with flexible deployment, whether it's on-prem or in the cloud, and enable scaling to large sort of deployments on premise or centralized. I want to highlight to you that essentially we have a promotional offer this year that every new customer that invests in new CSense licenses for the first time, we make available 6 hours of free get started consulting. And the whole purpose this year is just to quick start value delivery for a new customer. And so it's really 6 hourly structured sessions where I personally get to know the customers, the stakeholders. We make sure they have no installation issues. We help them connect to their data. And then for one use case, which are important to them, we show them how they can analyze, model, predict, or simulate, with the software. And this has been proven exceptionally popular, and often we got a lot of good value stories from this, where within the first 6 hours, customer often had brilliant new insights and already first value. If you ask, how do I as a system integrator, how can I build a practice? How can I enable? Well, the good news is, I think Tim, I'll hand back to Tim very soon, then he can talk a bit more about that. But in short, there are training courses that are freely available to you as system integrators, to our GE Digital System Integrator or Solution Provider community around Prophecy CSense, which you can use to sort of build some competencies. And also, if you want to learn more about the software, there is the link to the website. You'll find data sheets, access to free trials there. Actually, you'll find all our customer stories there. And there's also a YouTube channel with short 5-minute videos there where you can see basically how specific use cases can be implemented and addressed to analyze, model, predict, simulate, or optimize with CSense. And with that, I think we can spend a few minutes on Q&A. Thank you.
Thanks, Cobus. Great overview. So we do have one question that came in. And the question is, Prophecy CSense, is this a software module? How does the licensing work? And do we need dedicated workstation to run this application? What are the protocols supported?
So yes, it's a software module. Typically, the way you should think about it is typically customers put at least, your customer will need at least a runtime, a CSense Analytics runtime, at least one on every plant, possibly close to the control system where it can access historical data from the systems I mentioned, historians, maybe MES systems, also real-time data from via, from your SCADA, DCS or PLCs. And it generally interfaces with plant systems via standards. So, OPC, DA, and UA be an example, right? So typically through OPC, UA or DA real-time access, you can rewrite to your control systems for real-time control. And through historical access, you can often access your historian data, but it has native access to our own GE prophecy historian, for example, and some other historians, and also generally to SQL database sources for access to data from other relational systems like MES, raw material quality databases. But generally, just think of that your customer needs one runtime per plant, at least, to deploy analytics into production that will analyze, monitor, predict, or simulate or optimize the process in real time. And then with that runtime, they get one development license also, which can be used to develop, test, to analyze data, and to develop and test analytics before deployed to the runtime. And then they can obviously buy additional developer licenses as they need that. And Tim will allude to it, but for the system integrator community, if you are if you have access to the GE Digital System Integrator license keys, then CSense is also on there. So for internal development purposes, you will have full access to the CSense developer tools to develop and test solutions for your customers, but that will then have to be deployed to a runtime which the customer have purchased or subscribed to.
Yeah, and just to pile on to that, Cobus, yes, if you're in our solution provider program, you have full access to the development tools, access to support, access to all of our training modules. And you really, as an integrator, have two different ways you could approach this. So you could actually be that source of analysis and building that. So you do the development of it, you put the runtimes in, and then they come back to you as the resident expert each time they need changes made. Or you can get them a development license, and then you can teach them, train them to modify and tweak those as well. So there's two different ways to approach it. Cobus, got another question for you. So the question is it possible to connect multiple historians from different plants or data sources from different plants into one single prophecy CSense? So the one-to-many manufacturing facility model?
Yes, absolutely. As long as that CSense runtime has network access to the multiple historians, absolutely yes. So whether it's on-prem or whether it's a centralized runtime more on a sort of centralized, maybe head office level, or whether it sits in the cloud, as long as it has network access to the historians, a single CSense runtime, analytics deployed to a single CSense runtime can access read from write to multiple historians.
Okay. Another question that came in relative to several operations and IT systems which are possibly siloed. So maybe you're working with two different groups. Can you give some guidance or recommendation on how to overcome data set challenges? So if you're pulling information from different data sets in, any experience with that?
Absolutely. If you think about it, like I said, that's one of the challenges that customers face, is that maybe their raw material sits in one database, their MES data in another, their quality data in another, their historian data. So it's exactly the silos that are challenging. However, it's really important to minimize data duplication and to retain your single system record of truth. So system of record, single source of truth nature of your data. For example, a process historian, for good reason, should be the single source of truth for your sensor data. And you want to minimize duplicating that. So that's why utilize optimization or analytic software that can form an innovation layer on top of whatever diverse OT systems you have that can pull the data for specific analytic purposes or analysis optimization purposes, only the data needed from the various systems without duplication, and then essentially act on it. So, for example, CSense can easily, one of the strengths of it is it can access a diverse range of data sources easily and, combine that data, prepare, process it, model it, optimize it, and then act on it. For example, write out optimal suggested set points back to your control systems, historize it in your historians, visualize it in your existing visualization or in our standard web interfaces. So the answer to it is choose optimization layer that can easily access and pull data from wherever it's lying, but retain the single system of record, single source of truth, sources of those data, which is there for good reason. Avoid duplication where necessary. And sometimes it makes sense to centralize data. For example, plant historians to a central historian, or local systems to a cloud-based centralized historian. And so yes, if you choose to do that, then again, these optimization software can easily access that data from the central repository also. So those would be my comments.
All right. Just as a reminder, if you've got any questions, just feel free to put them into the Q&A chat session. Got another one here, I think is along that same theme on the silos, which is how can we use analytics to collaborate rather than compete on resources to optimize our operations?
That's a great question. I think that's exactly the power of and the value that these optimization software solutions can bring, and that is enable subject matter experts, whether they are sitting at the plant, to collaborate with maybe central experts or service providers like control system integrators, like the community that we are speaking to here. And really to form this collaborative partnership of service providers with local subject matter experts on plants, with maybe central subject matter experts at centers of excellence, to co-develop and test analytics that can then easily be deployed to analyze, model, predict, simulate, or optimize processes iteratively and continuously, deployed wherever it makes sense, on premise or centrally or in the cloud. And that is exactly the value, the sort of snowball effect. Rapid, iterative, continuous optimization of manufacturing plants where subject matter experts, whether local or central, can collaborate with across functions with service providers like control system integrators to optimize their productivity.
Great. Let's see. Here's one really around what is the best approach for building a digital optimization practice and becoming a domain expert. So if you're a systems integrator that's considering, hey, I've got customers that have a need for this, but I'm new to this space, what's the approach really to kind of ramping up and becoming an expert in the shortest amount of time? And Cobus, I can probably start with this and then you can pile on. So
Yes, please.
one of the things that I would first start with is really laying out a competency roadmap to ramp up the skills. So if you're going to be an expert and you're going to start to get into more of building a digital optimization practice, just try to figure out by individual who's going to need what skill set. So obviously there's somebody on the sales side, somebody on the marketing side, and then also the engineers that are going to actually deploy that. So what are the skill sets that are going to be needed, and where do I get that information? The second part would be more, I would recommend, which is kind of look at the information available. Like in our situation, what we do a lot with is if an SI has an opportunity and they're kind of new to it, they just reach out to me or to Cobus. And what we do is we set up a one-on-one session with our systems integrators to kind of review the opportunity and say, okay, let's walk you through that. And then let's get your guys a high level overview of what's needed. And then the third step is, get access to the products and the tools that are needed. So in our case, it could be C-Sense, it could be somebody else's product. But the whole idea is, be proactive and learn the tool before you need it, right? Because that'll give you the opportunity to play around with it. And then, the last thing is let us help you win with that customer. So we talked a little bit about, what we do with C-Sense and some of the other products is we have the consulting 1-hour sessions that we do with you. So build that right in. Your customer doesn't need to know that the C-Sense team or Cobus's team is helping you walk through that. So we can be there behind you, supporting you on discussions with your customers, helping with demos, helping with project guidance and stuff. And so we want to make you successful because obviously as a software company, we want to sell more licenses. So really those 4 things would be my recommendation on how do you become a domain expert and with your customer, how do you sound like an expert? Really just work with us and we can help get you there.
All right, Tim, I'm going to take over. You're getting the hook.
All right.
On behalf of CSIA, I would like to thank today's speakers for this informative discussion. I would also like to thank GE Digital for sponsoring the event, and of course, thank you for attending. Be sure to bookmark the CSIA events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thank you for joining us and have a great day.